Java basic concepts to advanced concepts are covered in this video, along with a mini project. Let's look at Java and start with an introduction. First, let's discuss what a program is. When we give instructions to a computer, we call these instructions a program. For the computer to understand these instructions, we need a programming language. Python, C, C++, and Java are some examples of programming languages. But why should we learn Java? Java is one of the most popular languages. If you look at the top 3 programming languages, Java will likely be included. Learning advanced Java can also make it easier to secure a job. Now, let's look at some applications of Java. Mobile apps, websites, game development, cloud-based applications, big data, and desktop applications. Java is used more and more across various fields. For any programming language, we start by writing code in a text editor. This is called source code, which programmers can understand. However, the computer doesn't understand this language directly. Instead, there's a process that handles the work for the computer to execute the code. Inside the processor, there are transistors and capacitors. Although it is small in size, there are millions of transistors and capacitors inside. Processors are manufactured using very large-scale integration. Many companies manufacture processors, like Intel, AMD, and many others. This processor executes the instructions we give, but the processor understands only zeros and ones. The lines we write are in high-level language, so the processor cannot understand them directly. This must be changed in a way that the processor can understand, and for that, we use a compiler. No matter what programming language you write in, you need a compiler to run that language. The compiler is also a program. What it does is read the lines we wrote and convert them into machine code, zeros and ones that the processor can understand, which we call machine code. Our written file will be converted to object code during compilation. We provide this file as input to the processor, which can understand it because it is machine code. The processor reads that and executes it. How does Java differ from other languages? In Java, we write code in a text editor, and while the processor still executes it, we use a compiler that does not directly convert it into machine code. Instead, it produces bytecode. This bytecode cannot be understood by the processor directly. This bytecode requires a JVM, Java Virtual Machine, to be understood by the processor. To use the Java Virtual Machine, JVM, we need to download it. When the bytecode is passed to the JVM, it converts the bytecode into machine code, which the processor can then execute. Whenever we write a program, we first compile it and then run it. When we compile, we get bytecode as output. When we run it, the JVM converts the bytecode into machine code for the processor to execute. In other languages, when we compile code, it creates an object file for the processor to understand. When we run this object file, it serves as input for the processor. In Java, however, this extra step of using bytecode and the JVM makes Java highly portable. For example, if we write code in C language and compile it on a Windows system, we need a C compiler that is compatible with Windows. Similarly, if we use a Mac, we need a C compiler compatible with Mac OS. If we compile and create an object file in Windows, that object file will only work on Windows. If we want to execute the same code on a Mac, we must recompile the source code with a Mac-compatible compiler. The object file is dependent on the type of system we use. In contrast, Java's bytecode can be executed on any system with a compatible JVM, making it platform independent. To solve this problem, Java introduced bytecode, Now, if I write a Java program in a text file and compile it, I get bytecode as output. Whether I compile it on Windows or Mac, the bytecode will be the same. The Java compiler is common across all systems, and its job is to convert source code into bytecode only. When we execute this bytecode, it needs to be converted into machine code, which is where the JVM, Java Virtual Machine, comes in. The JVM needs to be downloaded, depending on the type of system we are using, like Windows or Mac. If I'm working on a project and I compile it to bytecode, I can send this bytecode to any system. All they need is the appropriate JVM for their system to execute it. This is why Java is highly portable, and we call the JVM an interpreter. An interpreter works differently from a typical compiler. This bytecode does not get fully converted to machine code at once. Instead, the interpreter reads each line of bytecode and executes it line by line. In other languages, the compiler converts the entire program into a single file in machine language to be understood and executed by the processor. In Java, however, the interpreter reads and sends each line for execution individually, making Java's execution model different and more adaptable across systems.